All right. When an automobile travels uphill or downhill, it experiences a force due to gravity. This force, capital F in pounds, is the grade resistance, and it is modeled by the equation F equals W sine theta, where theta is the grade and W is the weight of the automobile. Okay, so we have some calculations to do. First, they want me to calculate F, the force due to gravity, to the nearest 10 pounds for a 5,500 pound car traveling uphill with a grade of theta equals 3.9. All right, so here's basically what's going on. I would draw myself a little right triangle, which basically represents my car going up a hill. So here's my little car. Going up a hill. Okay, so they give me a formula, F equals W sine theta. Well, I have everything I need. I'm trying to find the force. What was W again? What's W stand for? Yeah. Weight of the automobile, which they gave me, 5,500. And then I'm just going to multiply it by the sine of theta. And theta in this case is 3.9. So I will ask Mr. Calculator to do 5,500 times the sine of 3.9. So that means the force due to gravity is 374.08 pounds, but we are supposed to round to the nearest 10 pounds, right? So if you're going to round to the nearest 10 pounds, what is that? What does this number round to? Nearest 10 pounds. $370, correct. So what this means is you have this car going uphill at a pretty small angle. 3.9 is not a massively big angle, right? So, but it is going uphill. Gravity is pulling on that car straight down. And this is the force that gravity is pulling down on a car with a mass of 5,500 pounds. How interesting. So, if I wanted to lift this car up, you would need the weight of the car plus 370 pounds to counteract. All right, let's try B. Calculate F to the nearest 10 pounds for a 2,800 pound car traveling downhill with a grade of negative 4.8. Well, just because I'm going downhill doesn't really mean I have to change anything. That just makes my angle negative because I'm going downhill. So I get to use the same formula, F equals W times the sine of theta, and just pop in what you need. The weight this time is 2,800, and my new value, negative 4.8. So let's see what we get this time. Oh, that's so funny. My calculator gave it to me as this crazy fraction. Let me get this out of math type because I don't think I want that. I don't. I want it as a decimal. Oops. Oh my gosh, what is wrong with this thing? Oh, I gotta get it out of, let's put it in decimal. There we go. Okay, I got it now. Did you guys get negative 234.30? But then if I round that to the nearest 10 pounds, it would be negative 230. Okay, so now in part C, I don't know what the grade is. Grade is just theta, right? So it's theta that I don't know. So I'm going to start off with my same equation, but I don't know theta. What I do know is the weight is 2400, and where am I going to put this 288? F. Yeah, that's the force, is 288. So I put in 288 over here. The weight is 2400. Sine of theta. This time I don't know what theta is. How will I solve for it? What should the first thing that I do be? If I have this equation and I want to solve for this, I need to
isolate it.
Yeah, so let's get rid of this 2400. How? Yes, thank you. Divide both sides by 2400, right? If I'm multiplying by 2400, I'll divide by 2400. So now I have this crazy decimal. I don't know what 288 divided by 2400 is, but my calculator does. 0.12. So 0.12 equals the sine of theta. Okay, you do know how to get theta now. Don't you? Yes, what am I pushing on my calculator? Second sine and then 0.12. So I get 6.9. Does that make sense? Okay, so if you have this formula, it's pretty straightforward. Just remember what the pieces are. Force due to gravity, the weight, and then theta is just called this grade, the grade of the road or whatever I'm traveling on. Okay, that's pretty much it. So let me stop this here.